Hey everyone, and welcome to the Watch Before class for place value. Today's slides look a little bit different just because this is the way that it worked best for me for this one. So I don't have my Bitmoji and all of that, but that'll be back next time I see you in class. So today for this is going to be a pretty quick Watch Before class just to kind of prep us for what we're going to do in class. So what I'd like to do is create a shared vision for teaching place value, talk a little bit about place value foundations, and then in class, we're going to talk more about the progression from place value methods of solving problems to the standard algorithm, which is kind of where we want students to be eventually in elementary school. So in terms of creating a shared vision for teaching place value and just teaching arithmetic in general, I wanted to show you this quick video. I hope the sound is going to work. I've been working on that. So we will see. And what I'd like for you to do in this video, they're going to be solving one problem, and you're going to see a teacher kind of facilitating here. But I'd like you really to pay attention to the strategies that students are using to solve the problem. So if you need to grab some scratch paper, if you don't have some right next to you, just pause the video right here and go ahead and grab some scratch paper so you can just jot down some ideas about the strategies that students are using to solve this problem. Okay, so here is the video.
I'm going to give you the problem, but first we're going to try and read it to make sure that there's no problem in reading the words. Who can read the problem? Chris.
Kara has 48 cents in her pocket. Her big brother gave her 25 cents for running an errand. Now, how much does she have?
Okay. Your task today is to figure out how much Kira has.
I had 48. I counted 48 on the number board. I started from 48. And then I counted 25.
Go ahead
I
and
counted
count.
25.
Go ahead and count.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And I ended up with 73.
Excellent.
I started at 48.
And I went 10, 20, and then, no, that won't work. Hold on.
Go ahead. You're on the right track. Go ahead.
20. And I went
Right. Okay.
1, 2, 3, 4, 5, and that brought me to 73.
Very good.
First I wrote 48 and 25.
Okay.
Then I put these two in the save box. Then I did 40 plus 20 equals 60.
So we can write it 4 a little bit clearer so we can
Okay.
all understand it. Okay.
And then I made the 5 into a 2 and put 3 in the save box. So 8 plus 2 equals 10. 60 plus 10 equals 70. 70 plus 3 equals 73.
40. Plus 20 equals 60. And 60 equals 68, and 68 plus 5 equals 73. "48 plus 20 equals 68. 68 plus 2 from the 5, and 68 plus 2 from the 5 equals 70. Then I still have that 3 from the 5 to deal with, so then 70 plus 3 equals 73.
Okay, so that is a pretty interesting compilation of student solutions to an addition problem, right? So if you need to go back and watch it again, you can, of course. So you can go back in this video to watch that video. But again, what I really want you to pay attention to are the student strategies. And then the second thing I want you to notice is the way that the teacher ordered them. So she, I think, was pretty intentional about the way that she ordered the solution strategies in terms of presenting to the class in the specific order that we saw. So that's another thing I'd just like you to be kind of ready to comment on in class. Why would she do it that way? But much of what you're seeing in those in this video are what we call place value strategies for solving multi-digit problems. And the reason that's relevant now is because we've kind of already talked about basics of operations, but we're going to be talking about place value specifically, which really underlies the progression to multi-digit addition and subtraction, right? If you think about the standard algorithm that we use for it, or the way that we understand how numbers work, like we just saw in that video, we really need to have a strong foundation in place value for those things to actually make sense. Sure, anybody can copy the steps for the standard algorithm, but understanding place value ensures that your students will know why they're doing what they're doing. So that's going to be kind of our focus today and next class. So part of what I wanted to do today is just kind of lay this foundation for how we move into those place value strategies. The video was to create kind of a shared vision of what this can look like in classrooms. And now I want to talk a little bit more about the development. So if you think about the earliest grades, these are some of the things that are prerequisites to that multi-digit addition and subtraction. So these are leading us into our thinking about place value. And we've talked about a lot of these the past few weeks in class. And so what I want to do now is just one more time focus on subitizing, which we've done several times in class, but it's interesting because it's not only important to like the things we discussed in class, like multiplication and patterning and all of that, but it actually also lays the foundation for multi-digit addition and subtraction. It's one thing. So I'm going to show you some examples here. Okay, so when I look at this, I want you to just say the number that you see, just like we always do with subitizing. And you probably immediately thought 5 when you saw this shape because it's very familiar. This looks like a die, right? And so you're seeing this as a group of 5 because that's the way you're used to seeing 5, right? So now I want you to think about this, representation of 8, right? So many of you probably saw this as 5 from the prior slide, right? And then you're just adding on 3 more, and you knew that was 3 because you're familiar with that pattern. So this is an example of perceptual subitizing where you just have the 5, right? And then we talked about conceptual subitizing as taking 2 things and putting them together. So it's almost like having multiple things and then combining them. That's conceptual subitizing, okay? So perceptual, conceptual. And as a teacher, that's important to know because if you have students who can perceptually subitize but struggle with conceptual, then you kind of know where they are on the spectrum here. Okay, so I'm going to give you a few more examples of this. As I put the slide up, I want you to just to yourself say the number that you see and how you see it. Okay, so this is another example of 5, but it probably didn't come as quickly because you're not as familiar with this pattern, right? So the way we see the number makes an impact too. So to me, I saw this when I first saw it as 3, 1, and 1. I think a lot of people see it as 3 and 2, or a lot of people just count it from 1. Okay, so I'm going to show you some more examples here. Okay, so here, this is an example of the number 6 that you're familiar with from dice, and I see it as 3 and 3. You may have seen it differently, but that's the way I see it. So now let's look at another example. Okay, so another example of 6, but this time I'm seeing it as 5 and 1 because of the way that it's presented to me. So the way that I see the number is important as well as the way I subitize. Okay, another example. So again, we have 6, but this time you see it as 4 and 2. Okay, let's look at one more. Oh, just kidding. I took it out. Okay, so the point of these slides was to show that not only is that idea of subitizing important, but the way we see the number is important as well. So if you're trying to elicit certain strategies, you want to be mindful of the things that you're presenting to subitize, right? So if you're really trying to get kids to be automatic with this, then something like this might be more effective than what we saw prior with the 3 and the 2 for the 5. But if you want to be really intentional about giving more challenging things that students don't just automatically know, then that would be a good example. So there's all these different things to consider when you're thinking about subitizing. And that really helps lay the foundation for place value, because you'll see in just a moment. So these are kind of the next things that I want to look at. So specifically anchoring to 5. So again, we've talked about subitizing and how we can just build that basic number sense and the ways that we see numbers to build flexibility. So now when we look at anchoring to 5, we're going to do the same thing. So when I show you this figure, as a 5, many of you are familiar with a 5 frame, right? So you're seeing this as a complete 5 frame. And seeing a complete 5 frame as 5 is also another way of subitizing. So now we're just intentionally tying it to this anchor of 5. So we're going to do the same kind of exercise here. Okay, so many of you probably saw this as 5 and then taking away 1, which gives you the 4. So this introduces that idea of the relationship between numbers less than 5 and 5. So thinking about differences and relationships. Okay, and this one is a nice example of how to show a perceptual 5, right? And then 3 more. So you might have, this might encourage moving from subitizing or basic facts into counting on, which is the kind of the next stage, right? So you might have 5 and then 6, 7, 8. Many of you probably just saw it as 5 and 3, which would give you 8. Okay, then I want you to think about this example. So we had this example for 8 and this example for 8. So I want you to just pause here and think about kind of the benefits of each representation. What types of thinking might they encourage? What types of skills might they build? So pause here and let's think about that. Okay, so the next step in this is anchoring to 10. So same idea, right? So now we're going to be using a 10 frame. So same idea, anchoring to 10 and knowing that a full 10 frame is 10 is one way of subitizing. So I'm going to show you a few more examples here, and we're going to be doing the same thing. So just in your head, kind of saying what number you see. Okay, so this one, again, we have 2 5s. So hopefully you saw that was 10 right away as a conceptual subitizing task. And again, here I want you to pause and think about kind of what are the benefits of each type of representation of 10, because these are both showing the same number, but what types of thinking might they encourage? So the 5 and 5 here would be a real focus on subitizing and being able to conceptually subitize and combine those two things. Whereas the 10 frame might lead us more to this thinking about like a part whole model, or tagging on to a 5 frame or counting on, like we discussed before. Okay, this one. So probably many of you saw 10 and then take away 2, which would give you 8. Other students will see 5 and then add on 3, which will, of course, also give you 8. But again, this allows us to focus on those relationships and organizations. Okay, so now same thing, pause here and think about this representation of 8 versus this representation of 8. Okay, and then lastly, I wanted to show you this one, which can also encourage counting on, similar to the 5 and 3 that we saw. I've included different colors here, which helps too to kind of separate the groupings. But again, if we're trying to build counting on starting with 10, this really builds that idea of the 10 as the unit, right? So like a 10's place and then 3 more. So this is a really nice way to kind of ease our students into thinking about the number 13 as 10 ones and then 3 more ones, or a group of 10 and 3 more. So again, we're always thinking about how to lay that foundation for place value. All right. So the next thing I want to talk about is exploring basic fact strategies, including doubles strategies and making a 10. So again, these things are all going to lead into that idea of creating place value places and the thinking around groups of 10, groups of 100, etc. Instead of just digitizing everything as we do often in the algorithm. So here I want you to just pause and tell me what you see and how you're seeing it. Okay, so really what I'm going for here is the strategy of doubles plus one, right? So I can think of doubles, double sixes plus one more. Okay, so thinking in terms of strategy, I want you to look at the next one and think about the same thing. What strategy would you use? Okay, so this one lends itself more to making a 10, right? So I could take one of these from the 3 and put it here and make it 10 and then know that I have 2 more left over. I feel like I skipped one. Yes, okay, and then this was the doubles minus 1. Sorry, I skipped over that slide. So we've got doubles plus 1, doubles minus 1, and then making a 10. So you can give students these problems in a way where it really lends itself to that strategy, right? So, and that really helps again with those place value strategies. All right, so then the next 2 problems I'm going to give you, I want you to just think about how you could use a strategy to solve this. So not using what you know about the basic fact, but what strategy, thinking about doubles, making a 10, anchoring to 5, that kind of stuff. What strategy would you use to solve this problem? Okay, so I'll give you a second to think about that. Okay, and for this one, I would say I was thinking of this one as a make it 10 strategy, but I've also seen students kind of surprise me and do doubles plus 2. So 7 plus 7 plus 2, which is another great strategy. And it's a really nice contrast to that make it 10, and you can show why they give you the same answer. Okay, and then same with this one. So we have 8 plus some unknown value giving us 13. And as adults, we kind of think about this in a certain way. So I'm going to give you a moment just to think about that. Okay, so as adults, we often think of this as a subtraction problem, right? So we'll take subtraction, so 13 minus 8 to get this unknown value. But for students, that makes it's very confusing, right? Because it's an addition problem. So thinking about the strategies they might use to solve this. So using addition, you might have students who find the difference between 13 and 8 using STEM either counting up, right? Or they might count back from 13 to 8, or they might do subtraction. So there's all different ways of thinking about it, but students aren't, or children aren't automatically going to think of this as a part whole like we do. Okay, so then the last little bit of this I want to talk about are thinking about adding and subtracting using those place value strategies. So adding and subtracting to 10. So the hundreds chart is a really effective tool for this. And what I want you to do now is we're actually going to use this in class next time I see you. But thinking about the hundreds chart, I'm going to give you just a blank one here as an example, and I want you to pause here and just think about how the hundreds chart is organized. What are all the things you know about the hundreds chart? So pause the video here and just jot those down on your scratch paper. Okay, so the next little bit here, what I'd like to do is I'm going to show you 2 dots. I'm going to show you a red dot and a yellow dot. And your job here is going to be to describe the relationship of the yellow dot based on the red dot. So for example, this one, we know that the yellow is 1 more than, right? So even without the numbers there, we know based on what we know about the hundreds chart, what the relationship is of the yellow to the red. Okay, so I'm going to keep putting these up, and I want you just in your mind to tell me, well, tell yourself, I guess, what the relationship is. Okay, so this one will be 1 less than. This one we know would be 10 more than, because we're jumping 10, because we know that those row to row is plus 10. This one would be minus 20. Okay, this one is a little more difficult. So I just want you to pause and think about this one for a moment. Okay, so if you're back, then the way that students might do this and we might do this are different, right? So students might count up all the way to the red. I'm sorry, from the red all the way to the yellow. With us, we might be able to jump more, right? So I can see that from the red to the yellow, I'm going to go plus 10, 20, 30, 2. And so if I go from yellow to red, I'd go minus 10, 20, 30, 2. Okay. And often this is a good example of one that students might get confused with because you kind of have to keep track of whether you're going backwards or forwards. But it's really good to uncover those potential misconceptions using something like this, where it's really like you can put the numbers back and then you can talk about it in all kinds of different ways. Okay. And then this is another example of that. So pause here and figure this one out. Okay, then we have from red to yellow, right? So for me, I would go minus 10, 20, 30, 1, right? Or from yellow to red, I'd go plus 10, 20, 30, 1. So it kind of works both ways. So a really common wrong answer to this one is 29. So you could see how students might go 10, 20, 30, 29, right? So that's another important thing to kind of uncover and really focus on if you want students to get that patterning down. Okay, so thinking about conceptualizing the problem 12 plus 13, it might look something like this. So they're going to start at the 12, add 10, and then add 3 more. And you have to be a little bit careful with this because you don't want it to wrap around to the next row. That makes it a little more confusing, but this is a nice type of problem to give students practice with the hundreds chart. And again, the hundreds chart, the benefit is that it again trains our brain to do those jumps by 10, like we see in the standard place value that we use in numbers, right? So this builds that foundation as well and helps students build fluency around that. Okay, this is the last problem I'm going to give you today, and I want you to bring this to class with you. Okay, so you're going to use an open number line. And by open number line, I just mean I'm not giving you a pre-hashed number line. You're just drawing it and starting wherever you want and then solving this problem, however makes the most sense to you. So you're not using the standard algorithm. You are using an open number line to find this sum. Okay, so I want you to do that and then bring it to class and be ready to discuss. Okay, so I will see you next time where we're going to talk about place value more in depth, and we're going to get to play with some base 10 blocks, which is always a good time. So in the meantime, please just continue to check the syllabus, complete all your readings and watch before class videos. It's just this one this week. Keep an eye on your assignments and reach out with any questions. I'm available to you as always, and keep being awesome. I will see you next time.